Hello, this is the 6th video of the Linear Programming 2 series on the simplex method and integer programming for OCR Discrete Further Mathematics. And we'll be looking at using the simplex method for 3 variables. Here is a linear programming problem with 3 decision variables x, y and z. We're given an objective function and constraints, including non-negativity. First, let's write this in the augmented form that we looked at in the last video. So that would be p minus 6x minus 8y minus 10z set equal to 0. We'll also introduce the slack variables so that we have 2x plus 3y plus 2z plus s1 equals 10 and x plus 3y plus 2z plus s2 equal to 8. And the decision variables x, y, z plus the s1 and s2 slack variables must all be non-negative. We then input these values into the syntax tableau. So the objective function line going at the top will give us a 1 minus 6 minus 8 minus 10, no s1 and s2, and a right hand side value of 0. After that, I'm going to enter zeros in that first column to make sure that I get the coordinates for x and y in the correct columns. So then entering the constraints, I would have 2, 3, 2, 1, 0, 10 and 1, 3, 2, 0, 1, 8. I've entered therefore those 3 equations into the tableau. You'll remember the ratio test is therefore the right hand side values divided by the pivot column, and that the pivot column is chosen by the most negative entry, in this case the z column. So the ratio test will give me 0, and then 10 divided by 2 being 5 and 8 divided by 2 being 4. I'm looking for the smallest positive ratio test, which in this case was 4, and therefore this will be my pivot element. I know that I want that to be a 1, and therefore I would divide through that row by 2, giving me 0, 0.5, 1.5, the 1, the 0, 0.5 and a 4. I then want to carry out operations that will mean that this z column becomes 0, 0, 1. So for the objective function row, I will need to add 10 of this R3, remembering that this row is now the new R3 that I'm using. And the operation I will need on the first constraint row will be to take away 2 of that row 3. This would give us the figures of 1, minus 1, 7, 0, 0, 5 and 40 in the new objective function row. And 0, 1, 0, 0, 1, minus 1, 2 in that row. Note here that p has now risen from 0 to 40, that s1 has a value of 2, and that z has a value of 4. So we have moved from starting at the origin to the point 0, 0, 4. As expected, an increase in the z direction. X, Y and S2 are all 0. Looking at the ratio, we would see that we have a negative ratio test for the objective row function, and then a 2 and an 8. Therefore, this is the smallest positive ratio test. You'll note that the only negative in the objective row function is in the x column. Therefore, that would be our pivot column, and our pivot element will be that one there. We would not need to divide by anything, but I'll put divide by 1. And this now becomes our new row 2, which is actually the same. We would then need to try and make these two cells 0 by adding one lot of row 2 and by taking away a half of row 2. This leads us to 1, 0, 7, 0, 1, 4 and 42. So again, P has increased as we've moved in the x direction. And 0, 0, 1.5, 1, minus 0.5, 1 and 3. So reading that, we can see that P is now 42 at the point where x is 2, y is 0 and z is 3. So we've moved from 0, 0, 4 to the point 2, 0, 3. So we can tell which are the values because of those being the columns with the 1, 0, 0, which we then read off here. P is 42. 0, 1, 0, which we read off here, giving us x equals 2. And the 0, 0, 1, giving us z equals 3. The columns where we do not have just zeros and ones mean that those are equal to 0. So they are not coming in as the basic variables, they're non-basic variables. You need to make sure still that in free variables you can still interpret the simplex tableau at any stage. We know we have reached a solution because there are no longer any negative entries in the objective row. In other words, there is nothing to be gained by another iteration. And we have maximised P of a value of 42. In the next video, we will consider linear programming problems that require integer solutions.